Welcome! In this video, we're going to be going over Leetcode 226, Invert binary tree. So here's the problem on Leetcode, and a bit of trivia. Max Howell was the guy that created some software called Homebrew, and despite a bunch of Google employees using it, he failed to get a job there because he couldn't invert a binary tree on a whiteboard. Fortunately for us, inverting a binary tree is actually pretty straightforward. So I'm going to switch over to draw.io, and as you can see, I've replicated the binary tree that they gave us as an example. So 4271369, 4271369. Okay, so all you really have to do is traverse through the binary tree, and for each node, swap the left and right child. For example, starting at 4, you can swap 2 and 7. Now, the thing to be aware of is if you just directly copy one node to the other, you might lose a reference to the one that you copied over. For example, if I copied the one on the right onto the left, you can see that we lose the reference to the original left child. So what we have to do is actually save that child into a copy, and you can call it temp or so. So for example, I'm gonna have to copy child 2, and then once I do that, I can move 7 over here. Sorry, I can move 7 over here and 2 over here. So I successfully swapped it, and then you would have to do this for every node. So to continue on this iteration, we can go to the left child, and once we're over here, we want to swap 6 and 9. So to do that, we're gonna have to copy 6, move 9 over, and then move 6 back over here. So we swap those two as well. Now to continue this traversal, we can swap 9, but 9 has no children. And then we can swap 6, 6 has no children, and then we can go back up and swap the children for node 2. In this case, we're gonna have to swap 1 and 3. So we can do that by saving a reference of, saving a copy of 1, and then moving 3 over, and then moving 1 over. So we successfully inverted the binary tree. Now, before I jump into the code, I encourage you to try this yourself. It's actually pretty straightforward. I think you can probably get it. So now I'm going to switch over to my code editor. And as you can see here, I actually built out this tree. I'm doing a binary preorder traversal on it. And as you can see, it goes 4, 2, 1, 3, 7, 6, 9. This is before the inversion. So what we want to do is actually take this tree and invert it. So let's begin by creating a function. Const invert tree. Now this function is going to take in a parameter, and I'm going to call this parameter root, right? And since this is TypeScript, we want to give it some kind of data type. In this case, I actually created a generic tree node. I'm going to call it tree node with a generic type of number. Okay, and this function should return a tree node as well of the same generic type. Okay, so right off the bat, you'll see that there's an error on this return type, and that's because it is expecting us to return a tree node. So I'll just right off the bat return root. Okay, and it's complaining for some reason. Oh, that's because it's expecting an error. Okay, so I'm going to really quickly do a null check. So the first thing that we want to do is actually create that temporary variable, because remember, we don't want to lose a reference to the node being replaced. So let's just call it temp, and it will get a reference to our left node. So root.left. So now we can take the left node and copy the right node onto it. So root.right. Now the right node can contain whatever is in the temp. So root.right is equal to temp. So now we did the swapping. Now what we want to do next is actually continue the traversal of the binary tree. So we can do that by simply saying invert tree, root left, and invert tree, root right. Well, you're gonna see two errors right off the bat, and this is because it's complaining due to the fact that root left or root right might actually eventually return a null value. So to take care of that, I'm gonna type in the type annotation or null. So it can take in a tree node or it can take in a null value. And we're gonna have to do the same thing for the return value as well. Okay, in my binary preorder traversal, I'm going to pass in invert tree passed in with a T. Oh, and I made a typo here. I'm going to save that. And as you can see in my console log, I am doing a preorder traversal of the inverted tree. So 4796231. Okay. So let's test this code in Leetcode. I'm going to go to my JavaScript file and I'm going to copy this and paste it in here. And there you go, it passed. Apparently it's really slow, but it passed. So let me try submitting again. Sometimes the speed isn't very reliable, and now it's up to 58. I saw it at 80% at some point, but you know what? Let's just ignore that. So yeah, that's the algorithm. You can actually adjust this some more and optimize it, but this is a very straightforward approach and very easy to understand. I'm sure there are better ones and more optimal ones, but yeah, if you have a better solution, write it down in the comments. Well, thanks for watching. That's pretty much it. Remember to like and subscribe.